My name is Prem Thakur. PRN is 125B1F218. Title is Modulation in Data Communication. I am making this video under guidance of Professor Shweta Degasman. Modulation in Data Communication. This topic is very important first year engineering data communication because it explains how message travel over long distances. In daily life, we use many communication systems like mobile phone, GPS, television, 5G network, Wi-Fi, Bluetooth. In all these systems, information is transferred from one device to another in form of signal. But the original signal, like our voice or data, can't always travel directly over long distance. So we need technique called modulation. In simple words, modulation helps a message signal travel far by placing it on high frequency carrier signal. The first question is why do we need modulation? These are three main reasons. First is short range problem. Low frequency voice or data signal fade quickly. They can't travel so far on their own. For example, if I speak normally, my voice can reach only a short distance. Similarly, low frequency electric signal become very quickly. Second is antenna efficiency. For wireless communication, antenna is required. Low frequency signal need very large antennas, which are not practical. But high frequency carrier signals require smaller antennas, so they are useful in real world communication. Third is spectrum sharing. Different users and stations can use different carrier frequencies. For example, FM 98.3, FM 104.5, and AM 600 are different frequency lanes. Because of this, many stations can transmit at the same time without mixing. So, modulation need for long distance communication, practical antenna size, and proper sharing of frequency spectrum. Next is what is modulation? Now let's understand the definition. Modulation is the process of encoding a massive signal onto a signal carrier wave by varying its amplitude, frequency, or phase. There are three important signals here. First, the message signal, like original information we want to send, like voice, audio, video, or data. It is usually low frequency. Second is the carrier signal. This is the high frequency wave. It doesn't contain the actual message by itself, but it can travel fast and far. Third is modulation signal, modulated signal. When the message signal is added onto the carrier by changing amplitude, frequency, or phase, we get the modulated. The simple example is the message signal is like a passenger and carrier signal is like a vehicle. The passenger alone cannot travel far quickly, but with a vehicle it can travel long distance. Similarly, the carrier wave carries the message signal. Three properties we can change. A carrier wave is three main properties that we can't control. First is amplitude, second is frequency, and third is phase. So amplitude means the height or strength of the wave. If amplitude is high, the signal is strong. If amplitude is low, the signal is weak. Second, frequency. Frequency means how fast the wave oscillates or how many cycles it completes in 1 second. It is measured in hertz. Third is phase. Phase means the starting point or position of the wave in its cycle. These three properties gives us three types of modulation. If we vary amplitude, it is called amplitude modulation or AM. If we vary frequency, it is frequency modulation or FM. If we vary phase, it is called phase modulation or PM. Easy trick. AM is equal to height changes, FM is equal to speed or spacing changes, and last PM is equal to position changes. Amplitude modulation. Now let's discuss amplitude modulation or AM. In AM, the parameter change is amplitude. That means the height of carrier wave changes according to message signal. The carrier frequency stays fixed. When the message signal is strong, the carrier wave gets tall peaks. When the message signal is weak, the carrier wave gets short peaks. So we can say The AM wave looks like a breathing because it becomes taller and shorter. AM is used in AM radio, usually from 540 to 700 kHz, and it was also used in old analog TV systems. The main advantage of AM is it's simple to build and simple to decode. It also needs low bandwidth, but the disadvantage is that AM is easily affected by noise. Noise usually changes amplitude, so AM signal get disturbed easily. That is why AM radio may create crackling sound during thunderstorms. So the short summary is AM is simple but noisy. Frequency modulation. In FM, the parameter changes the frequency. Here amplitude doesn't change. The height of wave remains constant, but the wave oscillates faster or slower according to message signal. When message signal is high, the carrier signal oscillates faster. When the message signal is low, the carrier oscillates slower. So in the graph, we can see that the spacing between waves changes. Close waves means high frequency and far waves means low frequency. FM is used in FM radio, usually from 88 to 108 MHz. It is also used in cell phones and wireless audio systems. The biggest advantage of FM is excellent noise immunity. Since noise is usually affect amplitude and FM does not depend on amplitude changes. FM gives better sound quality than AM. But the disadvantage is FM needs more bandwidth. It needs around 5 times more bandwidth than AM. So the summary is FM is clearer than AM but need more bandwidth. Third is phase modulation. PM. In PM, parameter changes phase. Phase means the starting point or position of the wave. In phase modulation, the wave shifts its position according to message signal. Here, amplitude remains constant, and the base frequency also remains constant. Only the phase changes. PM is very important in digital communication. For example, in digital PM like BPSK, bit 0 can be represented by 0 degrees and bit 1 can be represented by 180 degrees. So the receiver checks the phase and understand whether 0 or 1. PM is used in cell phones, satellites, satellite communication, Wi-Fi, and 5G systems. The main advantage of PM is excellent noise immunity, and it's ideal for digital signal. But disadvantage is need it needs complex decoder hardware. The receiver must detect phase changes accurately. So short summary is PM is best for digital communication, but it is complex. Now these slides compare AM, PM, and FM. In AM, amplitude changes, in FM, frequency changes, and in PM, phase changes. For noise immunity, AM has pure noise immunity because noise affects amplitude. FM is excellent noise immunity because information stored in frequency changes. PM also has excellent noise immunity because information stored in phase changes. For bandwidth, AM needs around 2 times message bandwidth. FM needs around 10 times message bandwidth. PM also needs 10 times message bandwidth depending on the system. For complexity, AM is simple, FM is moderate, PM is complex. For real-world use, AM used in AM radio and old TV. FM is used in FM radio and phones. FM is used in FM radio and phones. PM is used in Wi-Fi, satellite communication, and 5G. The key line remember is to M is equal to simple but noisy, FM is equal to clear but spectrum hungry, PM is best for digital but complex. Modulation in everyday life. Now let's see where modulation is used in daily life. First is radio. AM radio uses amplitude modulation and FM radio uses frequency modulation. That's why FM radio usually gives better sound quality than AM radio. Second is TV. Old analog TV used AM for video and FM for audio. Today, digital TV uses advanced digital modulation techniques. Third is mobile communication. 4G and 5G use advanced modulation techniques like OFDM, which means orthogonal frequency division multiplexing. In simple words, it divides data into many small carrier waves, so data transmission becomes faster and more reliable. Fourth is Wi-Fi and Bluetooth. Wi-Fi uses OFDM for high-speed wireless communication. Bluetooth uses frequency hopping, where it changes frequency quickly to reduce interference. So whenever we make a call, connect to Wi-Fi, use Bluetooth earphones, or listen to radio, modulation is working in the background. Now I will conclude my presentation. The first takeaway is modulation is needed because low frequency signal can't travel long distance efficiently. Second is modulation works by changing amplitude, frequency, or phase. A frequency carrier signal according to message signal. The third takeaway is AM changes amplitude, PM changes frequency, and FM changes phase. The fourth is AM is simple but noisy. FM is clear but needs more bandwidth. And PM is digital friendly but complex. And the final takeaway is modulation used in almost every wireless communication system from AM radio to 5G. So in one sentence, modulation is technique that carries our message over long distance by using high frequency carrier wave. Thank you. That's all from my side.